Hey, this is CUSD, Math 7, Unit 5, Lesson 12, looking at negative rates today. Alright, the first two problems are as part of your cool down to kind of wrap up or summarize the lesson from today. So they're ones that you'll do on your own. I'll talk through them real quick. Sometimes on a problem like today or a packet like today, most kids will tend to skip this lesson completely in terms of their homework because why? There are lots of words, and we don't like words. Seems to be the case with most of our kids. So let's just at least read it together, because I think once you get to the words of it, you're going to say it's not too bad. So the first one says, a submarine is descending. It's going down to examine the seafloor 2,100 feet below the surface. All right. It takes a submarine 2 hours to make that descent. So it takes 2 hours to go that far. Write an equation to represent the relationship between the submarine's elevation and time. Okay, so if you think about a chart, okay, how far it goes down depends on the time, right? So we have our independent variable and our dependent variable. So which thing is going to depend on which? Well, the elevation is going to depend upon how much time has gone on. So time becomes our x value, and elevation becomes our y value. This is our x and this is our y. You okay with that so far? What we know is that it's descending to the seafloor to 2,100 feet below the surface, okay? And it takes 2 hours to get there. So the time that we're given is, we know a 2-hour time, and we know an elevation of 2,100, okay? So I can put that in the table like this because I know that the elevation depends on the time it's been going down. Now, to make any kind of equation, I have to have an x and a y, but I also need what? I need a k. I need a constant of proportionality, which is found by y over x. This is back what we did in Unit 2. And in our case here, our y value is 2,100, and our x value is 2, and we can reduce that down to what? That reduces down to, well, in this case here, this is 1,050 becomes our k value. Now in the equation is going to be y equals k times x. And at this point, all we have to do is plug our value of k into the equation, and now we have an equation that represents that, that situation there. Okay? So, I didn't give you the answer fully, but I got you pretty close. Alright, another submarine's descent can be represented as y equals negative 40x. And I probably, looking at this one, tells me I gotta make sure on your notes here, yes, we have 150, but notice that it's a descent. So we kept on this one, the k value is a negative k value. So probably keep that in mind for this one too. We probably need a negative k value over here. Alright? So on this one here, the rate is going down negative 240 feet for every, whatever the time is going to be, every hour. So y is elevation, x is time, same thing. How long would it take the submarine to make the descent? So the question here is, if you use this equation, how long, so we're talking about how much time will it take to make the descent. Well, what is the descent we're talking about? The same one that's here, 2,100. So we're given an elevation. The elevation was which value? Elevation was the y value. So if the elevation is a y value, we take the equation, negative 240x, and we need to take this value and plug that into y and then solve for x. So that's what it's asking you to do there. Okay, so it's not that it's too super complicated. It just is going to be, a little more work than maybe what you're used to, or you have to really think through it. That's what these problems are like. They want you to persevere and keep going. So don't give up on them. Just try them and just think through, what could it be asking me? How can I solve it? You know the tools, you know the ideas. You just got to put it all together. All right, let's look at number 3. Actually, 3. I'm gonna skip 3. Okay, I'm going to skip that one. And then it says, describe a situation where each of the following quantities might be useful. When might you use negative 10 feet per second? When might you use negative 1.2 milliliters per second? That's usually like a liquid, right? And that's a distance. Let's look at 4. So the bathtub empties water at a rate of negative 4.75 gallons per minute. So that's our rate. If it took 7 minutes to drain completely, all right, there's minutes, we have 7. How many gallons of water were in the tub to begin with? So What's happening here? We have a rate going on. After, if you think of it this way, we have our minutes, right? And we have our gallons. And at our rate right now, after 1 minute, we've gone down negative 4.75 gallons. That's our rate. Okay? So, the question here is, if everything is empty at 7 minutes, right, how many gallons have gone out at 7 minutes? So, using our table here, we could continue this and say, well, to go from 1 to 7 is multiplying by 7, and then we multiply this by 7, and we get that solution. Okay, that's the idea for how this is working. So I'll let you figure that one out. You got enough there to help get you going. Number 5, the river's shoreline recedes in the drier months by negative 5/6 inch per month. So that becomes our rate. How much has the river receded after 8 months? So again, the same idea. We have months, and then we have the shoreline receding. Right? So after 1 month, it recedes negative 5/6 inches. And what they're asking here is what happens after 8 months. So what happens here? So again, to go from 1 to 8 is multiplying by 8, and we do the same thing over here to figure out what that value is going to be. Keep in mind that it's a negative number, and that's all right there. All right, number 6 just says J and K are numbers. Doesn't say what they are. J plus K equals 0. Which statement below are true? So if these two numbers add up to equal 0, which ones are true? So the idea on these things is maybe think of a couple numbers. Think of a number like 1 plus negative 1. That equals 0, right? So if that's the case, if those are the numbers, would these make sense? Okay, and then you decide. That's not what they are. It's just a question, something to think about. Use some real numbers to help you figure that out. All right, number 7. We have several here. It says evaluate each expression. When the answer is not a whole number, write your answer as a fraction. All right, I'm going to go ahead and do A. All right, so we have 1/2 divided by negative 4. Well, divided by negative 4 is divided by negative 4 over 1. And so when I'm dividing by that number, I'm going to multiply by the reciprocal. Don't lose my negative. And then multiply goes straight across. 1 times 1 is 1. 4 times 2 is 8. And it's still a negative answer. So negative 1/8 right there. All right. And that's what we got. Looking at my notes, I did my notes wrong. This was the better answer. Sometimes I make mistakes. I had a student the other day come and say, hey, Mr. Morgan, you did that one wrong. Perfect. I'm glad you figured it out. I'm just doing them quickly, you know, with my .cam, trying to get through them all to help you out. If I mess up, that's okay. I don't mind. Find that problem and point it out. Show your teacher and say, hey, I got it right. Mr. Morgan got it wrong. That's great. You're learning. I love it. Okay, last one here. Represent the following problem with a diagram, a number line, equation, and then solve it. Okay, so I'm going to draw a picture real quick and then let you figure out the rest. It says a weather balloon is 50,000 feet above the sea level. So here's the sea level, and we have a weather balloon hanging up here, and it is 50,000 feet from here to here. So this distance right here is 50,000 feet. And a submarine is 3 miles. Here's our submarine. I don't know how to draw a submarine. All right, submarine is 3 miles below sea level. So 50,000 feet above, 3,000 miles below, directly under the weather balloon. How far apart are the submarine and the weather balloon? So from here to here is our question. What is this combined distance going to be? So it is a difference, but it's also, you know, it's positive. We're talking about magnitude. The other information they give a hint is that they're 5,280 feet inside of 1 mile. Because I'm not going to say 3 miles plus 50,000 feet. I need to convert this into feet. 3 miles times 5,280 will give me a number of feet. And then when I combine those two together, that's going to give me my answer. Okay, so there's a little diagram there, drawing a picture of what that looks like. You can use a number line to show it. This is almost like a number line here. Okay, in that regard, you just do that in a different direction. And you can see I've started to make an equation there too. So A lot of info there. You work that out. It's a great problem. See how you do. Okay, until next time, have a great day.